Okay, so again, we're going to have our object right here. Distance of the object is going to be 6. Height of the object is going to be 2. Our focal length, remember, is always going to be behind the mirror here. For this convex mirror, it's going to be behind. And then the center of curvature is twice the focal length. So we're going to follow the same basic rules, but we're going to use this as our guide. In other words, light is not going to reflect towards the focal point. It's going to reflect away from the focal point. So we're not actually sending it through the focal point, we're reflecting it away from the focal point. So what's our first beam? We're going to draw a parallel line. And again, we're going to go to this vertical line here just for accuracy. This is beam number 1. So, see, I'll summarize it down here. Beam number 1 is going to be through the focal point. Sorry, not through the focal point. Parallel. Spelled that wrong. Great. Parallel line. And then it's going to reflect, and it's not going to reflect through the focal. So here's what you're going to do. You're going to take your ruler. You're going to line it up with the focal, but it never actually goes through the focal. It reflects away from the focal. Okay, so this should be lined up with your focal point over here. And then you're just going to send it up away. Okay, so you send your parallel line, reflects away. All right, what's beam number 2? With the concave mirrors, what do we do with beam number 2? Through the focal, and then what? And then parallel. So this time what you're going to do, it's never going to go through the focal, but we're going to aim it with the focal. This is probably the line that gives people the most trouble. You're going to aim it with the focal and then reflect it parallel. So you take your ruler, you're going to line it up with the focal like this. However, it never actually makes it to the focal. So you send it towards the mirror like that. And then when it hits the mirror, it's going to reflect parallel. Okay, so it should look like that. So that's beam number 2. And what was beam 3? Through the center. Yeah, and we're going to do the same thing, but just like before, it never actually goes through the center. So you aim it up with the center like this. And it just reflects back because it's going to hit the mirror right on the normal. At this location, it's going to hit right on the normal. And therefore, it's just going to keep on going. Okay, so it's right at number 3. Aim with center. Straight back. So it doesn't change its angle at all. It's just going to maintain. Hits at 0, so it's going to reflect at 0. So what do you notice about these 3 beams?
They don't connect.
Okay, and there's a sciencey word for that when they don't connect. What's that called?
Diverge.
They diverge. So these 3 beams are diverging from each other. So what you're going to do is that same concept we did yesterday when we had this same effect. In other words, if you're looking at these beams, according to your eye, light should travel in a straight line. So even though it's diverging, it doesn't intersect, doesn't truly intersect. According to your eyes, it looks like it could be coming from a place on the opposite side of the mirror. So what you're going to do is you're going to send back these 3 beams and look for the intersection. All right? So one big mistake that people always make, especially with this one, if you notice, if you look close to the mirror, there's 1, 2, 3, 4, 5 beams. And so a lot of people send back the wrong ones. Just remember, you're sending back the reflected beams. The concept is your eye, what goes into your eye sees in a straight line. So you're sending back those reflected beams back into to the other side. Okay, so just go ahead and do it. So number 1 is pretty easy because it's aimed with the focal. So just go ahead and send it on through. I usually use dotted lines just so you know it's not really, there's not light there. It's not laser light going through here. It's just your brain's perception. Okay, beam number 2. This one's the parallel one. And then beam number 3. This was the one that was aimed with the center. Right there. So if you did it correctly, you should have a nice 3-way intersection right here. Okay. Remember, this is the tip of the arrow. This represents the tip of the arrow, so we'll just go ahead and draw in the rest of the arrow. Okay, there's our image. What do you notice about that image? Smaller, it's upright. Is this a real or a virtual image here? Again, it doesn't actually exist. If you put a screen there, it's not going to show up. It's just your brain's perception. You have to be looking at it for that to be there. Okay? So your eye has to be looking through there to see it. Okay, let's just measure it, and then we'll do the math on this. See how good our drawings are. So my DI looks like it's about 2.3. Is that about what you guys are getting? 2.4 maybe, 2.3, 2.2, 2.5. We'll find out who's closest. 2.8? 3.8. Okay, let's measure the height. I'm getting about 0.7. 0.7 for a height. 0.7 or 0.8, something like that. Okay, let's do the math on this. So the equation's going to be the same. 1 over f equals 1 over di plus 1 over do. The big thing you have to do with this, though, is this type of mirror has a negative focal length. If you plug in a positive, then it's going to give you the answer as if it was the concave mirror with that focal length. So just be careful. So we're going to plug in a -4 for our focal length. Okay, let's see what DI we should have gotten. If we did it perfect. Someone got the answer. Hopefully it's close to 2.3 or negative 2.3. Should be getting a negative number for this. And why should our DI be negative? Okay, it's on the opposite side of the mirror, right? So you should be getting a negative DI. 2.4? Okay, let's go ahead and calculate the HI. See what you should be getting for HI. So HI, my HO was 2. DI is negative 2.4. And DO was 6. What's our HI? 0.8? Positive or negative? And what's the meaning of a positive height? And lastly, let's get the magnification M. M, if you remember, is HI over HO. So 0.8 divided by 2, right? Positive 0.4. Positive means what? Means upright. And what is the 0.4 telling us? Smaller. Okay, so remember 1 would be the exact same size. So less than 1 is smaller, greater than 1 is larger.